All right, ladies and gentlemen, we are going to go through and reflect on the major mistakes we made in the Indices and Surds test. And I do think that this is one of the most important tests going forward to making your decision as to whether you want to go into math methods or not. Now, I did talk about, very quickly, I talked about that a lot of students expand and simplify. So this one in particular, I saw a lot of students do this. They did the square root of 9 times the square root of 12. In actual fact, though, if you found the highest common perfect square, of course, you could have gone the square root of 36 times the square root of 3. So my hint to you, square root of 36 is 6. So the answer is 6 root 3. So if you did it this way, you would have had to do that 3 root 12. But a lot of you left it as root 12. It's okay. But we know that root 12 is 3 times root 4 times 3, which is the square root of 4 is 2. That is 6 root 3. Okay? Now, quite a few of these were done, like if I've got 5 root 5s, these are common, these terms are in common. Okay? So these are terms which are like. So if I've got 5 root 5s and I've got subtract 1 root 5, I've got 4 root 5s. This one was also a very common one. Now root 32 is the same as root 16 times 2. And minus 8, root 8, is 4 times 2. Now then that's going to be the square root of 16 is 4. So that's going to be 4 root 2. Then I have 2 root 2s. And of course, a lot of you just sort of simply left that as root 8, which is actually correct, but that is 2 root 2. So when they say simplify, a lot of you had an answer of root 8. Okay, now you might have lost, you should have lost half a mark for that. Now, this one was done fairly well, which was because we didn't really have to simplify anything. We just had to collect our like terms. If you want, get your like terms, and then you can put a line under those. Then you can put like a square around those and a square around those. It was mainly sign errors, which I noticed. This one, I saw some students do some silly things such as adding, like doing this, root 8. Okay, that I think would be probably because, well, we make those silly mistakes. We've got to learn from them. Okay, over here, remember, multiply the numbers. The numbers, 2 times 4 is 8. 8 root 26, there is no factors of 26, which gives us a perfect square. So we're done with that. Over here, let's simplify this thing here. 12 over 4 is 3. Now, at the same time, that's the same as 3 over 30 over 5 is the same thing as we have there. 30 over 5 is 6, so the answer is 3 root 6. This one was done really well. This one was done very poorly, so I'm going to go through it with you right now. Root 7 times root 8 is root 56. Now, I saw most of you got that answer, that's right. Now, let's do the first. Let's do the outside. So we're going to do root 7, so that's plus root 21. And then let's do the inside. With the minus, though, minus root 120. And then let's do the last one, which is minus root 45. Now, look, that would have got you 1 mark. But you have to simplify. These surds are not simplified. And so what we're going to do is you could do, well, we can have, that's the square root of 14 times 4. You could have done 7 times 8 and eventually worked your way there, but that would be probably the best way to do it. Okay, and this is root 21. There's no perfect square which goes into 21. So we're going to call that plus root 21. Root 120. Now, we've got quite a few things which can go into there, but we can go 4 and 30. So that's minus 4 times And 45 is 9 times 5. Now, that's going to give us 2 root 14 plus root 21 minus 2 root 30 and then minus 3 root 5. Now, not many students could actually get full marks for that. A lot of you only ever got 1 mark out of 2 marks for that one. This one was done actually quite very well. Okay, this is what we call the difference of squares. Okay, because we can see here we've got root 6 minus root 5 and root 5 plus root 6. Now, so what we're going to do is we can say that, okay, it's root 30, then we've got a minus root 30, then we've got a minus 5 times, root 5 times root 5 is 5. So we've got a minus 5, and then we've got a plus root 6 times root 6 is 6. 6 minus 5 is equal to 1. Okay, so we probably got at least half the students. These questions were all done really well with the exception of this one, okay, because a lot of students, it's 3 to the power of 4. Remember, there's a little 1 here, okay, little 1 here. And what we then have to do is, then a lot of you got D4, E4, but of course you've got to simplify that. 3 to the power of 4 is 81. So the answer is 81, D to the power of 4, E to the power of 4. Now over here, there's students have had some issues with dealing with these numbers. So we've had the 32. Let's just leave the 32 where it was. That's F to the power of 5, but be careful, that's 2 to the power of 1 times 5, which is 2 to the power of 5, G to the power of 5. Now, 2 to the power of 5 is 32. Now, you didn't have your calculators in this test, so I can understand why some of you, but I really do think that you need to try to. There's an exam in methods where you can't use a calculator, and you're going to have to make those calculations by yourself. The powers of 2s and 3s and 4s up to, say, 5 or 6 would be very helpful, okay? Particularly for powers of 2, powers of 3. Do you need to know the 4 to the power of 7? Absolutely not. Okay, so that's 32, F5 over G5, and of course those 32s cancel out. So quite a few of you made that mistake. This one was done really well because anything to the power of 0 in brackets is 1, 5 times 1 is 5. So that one was done well. This one not so well. First of all, change this one automatically to this. If you did that, you would realise that we can get that power to the negative, and we can bring it up to the top, can't we? So that's B4C to the power of 3. Now, I can't go through too much in 2 minutes, but what I can do is you have to multiply by root 6 plus root 2. A lot of you multiplied by root 6 minus root 2, and that's not going to rationalise anything. Okay, so that you'll need to revise that. The answer ended up being 4, and you've got a root 6 plus root 2. But when you do the bottom thing, root 6 plus root 2, then the answer is actually going to be rational, and which was 6 minus 2, which is 4. And of course, now that we've got inside our brackets, we've got 4 divided by 4, the answer was root 6 plus root 2. Now, this one is when I think that we really struggle with these ones. Let's get it to a base smaller. Let's change and use brackets. This is mathematical notation. Let's change that 4 to a 2 squared. And then let's do that to the power of 3 over 2. Now, of course, you know in the index laws, we multiply, don't we? So 2 times 3 on 2. I could do it over the side over here if I wanted to do it. 2 times 3 on 2 is equal to 3. So that's the same as 2 to the power of 3, which we know as 8. All right. Same thing over here. Let's change 32 to a smaller base. That's 2 to the power of 5. X to the power of 10 over to the power of 1/5. Now, 5 times a fifth is what? 5 times a fifth is 1. So it's 2 to the power of 1, which is 2 over and 10 times 1/5. 2x to the power of 2. And finally, this is the worst. This was done the worst. So you need to really pay attention to this. Let's change to the same base. 2 to the power of 3. Use your brackets. X. 2 to the power of 4. So therefore, please start using this notation. Therefore, 2 to the power of 3x is equal to 2 to the power of 4. I now have those indices of the same base. So we can say that 3x is equal to 4, which means that x is equal to 4/3. What base can I get here? 25 and 125. What base? We can get a much smaller base than 125. 5. So 5 squared brackets x plus 2 is equal to 5. 5 to the power of what is 125? 3. Okay. X. Now we've got 5 to the power of 2x plus 4 is equal to 5 to the power of 3x. So therefore, 2x plus 4 is equal to 3x. X is equal to 4. Now I'm going to stop you there. I'll send you out my solutions, all right? But in the meantime, what you need to do is you need to make sure you look over your test, you correct your mistakes, reflect on how those mistakes you made, and next lesson, we're looking at financial maths. Any questions? Nope? Okay. Thanks, everyone. We'll see you tomorrow. See you Wednesday.